Okay, so this is the second part of my loops video about using for and while loops and storing the values in vectors. I'm going to talk about while loops specifically in this video because I think they are causing a little bit more confusion than for loops. And I get questions asking, when would I use a for loop and when would I use a while loop? The answer is that you can often use either one, kind of in the way that I showed in the last video where I used a for loop or a while loop to do the same thing. I created the same vector using those loops. For loops are great, so let me write this down. I'll just do it as a comment here. For loops are great when you know how many loop iterations you need to complete the problem. So in the case of a vector that you're trying to create, if you know how many elements are going to be in that vector, it's a good indication you might want to use a for loop because you can set a start and an end to that loop, like a definitive endpoint. While loops are great when you don't know how many times a loop will need to run, or you don't know how many iterations you need. I'm going to show you an example of that in this video where I'm doing kind of a simple example so you could figure out in theory how many times you would have to run this loop. But if I ran these examples for larger numbers, like 1,000 different numbers, I might not know how many times I would need this loop to run. So I'm going to show kind of an example of that here. Let me get rid of this. All right, so my while loop is going to be pretty simple. I'm just going to start off with a value of 10. And for my while loop, I'm going to say while x is greater than 0, I'm going to subtract 3 from x. So I'm going to say x equals x minus 3, and end. Notice that I need to overwrite x in this case because I'm using x as my condition. If I don't update x itself, my condition will never be not satisfied, I guess. So we want this to be false at some point because we need the loop to end at some point. If this is never false, we'll run into an infinite loop just like we saw in the last video. So I'm updating x at each step. And at some point, because I'm subtracting a number from a positive number, at some point x will be less than 0 and this loop will end. So you could think about it for a second and figure out how many times this loop is going to run, but maybe like if I had put like x is 2,374,000, maybe you wouldn't know how many times this would run for you to satisfy this condition. So we're going to see how this works right now. So let's start off by thinking about this table I have on the right hand side. I'm going to keep track of which iteration I'm in. So before the loop even starts, x is set equal to 10. So you'll notice this because I put x equals 10 here, and the loop has not started yet. The loop is down here. And remember, MATLAB runs each line in order from top to bottom. Okay. All right, so when we enter the loop, so our first loop iteration, we ask, is x greater than 0? Right now, x equals 10, so it is indeed greater than 0. So I will overwrite it to be itself minus 3. In this case, x will be overwritten to be 10 minus 3. So now x will have the new value of 7. Okay. So over here, x has a value of 7. And then I go back and I ask the question, is x greater than 0? Well, x is 7 right now, so it is greater than 0. And so I will go ahead and compute this next step. So at the next step, we're going to get x. X will be itself, which at this point is 7, minus 3. So x is going to now be updated to 4. So if I go over here, second loop iteration, x gets updated to 4. And we ask again, is x greater than 0? It is, because it's equal to 4. So it'll get updated to itself. So 4 minus 3, it'll be updated to 1. So in the third time this loop runs, x gets updated to 1. Now I ask again, is x greater than 0? X at this point is 1, so I will enter the loop again and compute that value. So at this point, x is going to be equal to itself minus 3. So x will take on the value of negative 2. Okay, so in the fourth iteration, x is negative 2. Now, when I ask is x greater than 0, the answer is no, because x has a value of negative 2 now, which means that this loop will end at that point. So here we exit the loop. One thing you might be surprised about is that we got a negative number, even though our condition was when x is greater than 0. And this happens a lot because unless we subtracted a number where we would land exactly on 0, it's totally likely that we would get a negative number when we're doing a loop like this that seems to go against what we might expect. So notice that in the third step, this value of x still made the condition true. 1 is greater than 0, so of course it's going to enter the loop and it'll compute this value. And at that point, that's when we get the negative 2 value. But that's also the point that we broke this condition and now we exit the loop. So we don't continue after this point. Okay, so notice that in my table here, in the previous video I had a table where I had a vector v and it was getting longer at each step and you could see all of the values that had previously been computed. Here, x is getting overwritten at each step. So at the end of this loop, x will just equal negative 2. It will have no memory of its previous values. I'll have no record of those values. I just have that x is 2. So when I go in here and I run this section, I just get that x is 2. So you can see I didn't suppress the output here, so you can see all the values. But if I enter x and I hit enter on my keyboard, I just have x equals negative 2. I don't have any of the previous values. So on the homework, or in other cases, maybe other programs that you're writing, you might need to keep track of what those values were previously in the loop. So I'm going to show you how to create a vector that would keep track of those values using a while loop. So I'm going to do that right over here so we can compare. So I'm going to start off with x equals 10, just like we did before. And I'm going to write a while loop while x is greater than 0. So it's the same while loop. While x is greater than 0, x equals x minus 3, end. So how are we going to keep track of this? Well, this is the value I want to keep track of, right? So I'm going to create a new vector, and I'm going to say that the kth element of that vector is going to be x. So I have to tell you what k is going to be, but this is the main idea, is that I created this vector here, and I want to keep track of x inside one of the elements of this vector. Okay, now the big question is, what is k? Because this code right now will give me errors. If I try to run this code, I get errors. It ran the first line, it ran this line, and then it said unrecognized variable k, because k does not exist yet. In a for loop, the loop index is initialized automatically, but in a while loop it is not. So I need to initialize k. The first value that I want k to take is 1. So I want the first element of v to be that first, this first computation of x. So k will start out as 1. I'm going to go down and get my new table here so I can keep track of everything. And now, if I run this, I'm just going to be overriding, so let's try running this. I just get that v equals negative 2 because k equals 1 every single step of this loop, every single iteration. So I'm always overriding the first element of this vector. So I need to update k. I need k to increase by 1 at every step. So I'm going to put k equals k plus 1. Okay. So now when I run this section, I get that v is this vector here, and we're gonna go through the whole step on the right hand side, and k is 5. Let me clear this. All right. So the first iteration. So actually, let's do before the loop. Before the loop is these two lines: x equals 10 and k equals 1. So before the loop even starts, x is 10 and k is 1. V doesn't exist. Okay, because it doesn't exist until I get inside the loop. So we ask the question, is x greater than 0? X is 10, so it is, and we enter the loop. So the first loop iteration, we set x equal to 10 minus 3, which is 7. And now k equals 1 at this step. So I'm saying that v, the first element of v is going to be 7. That's because x was updated at this step. Now I'm storing it in the first element of v. So v now is a vector with one element, which is 7. And now k gets updated, just like we saw in the first video, gets updated to itself plus 1. So k is going to be itself, which is 1, plus 1. So k is now 2. So I'm going to put that in my first iteration there. Now I go to the second iteration. I ask, is x greater than 0? At this point, x is 7, so it is indeed greater than 0. X gets updated to itself minus 3, so that'll be 4. Now v gets indexed, so I've got the kth element, so right now k is 2, so I'm going to get v parentheses 2 is equal to x, and right now x is 4. Okay, so I'm going to update that in my table here. V gets updated to 7, 4, because I just added that element in the second slot. And then at this next line, k gets updated to itself plus 1. So 2 plus 1 is 3. All right, now we go up to the third iteration. We check, is 4 greater than 0? We're asking, is this condition true? It is. So x gets overwritten to be 4 minus 3, which is 1. Whoops, 1. The third element of v, so remember k now is 3, so the third element of v gets set to 1. Okay, so we have that v now is 7, 4, 1, and k gets updated to itself plus 1. So itself, right there's 3, 3 plus 1 is 4. All right, we go now to the fourth iteration. Is 1 greater than 0? It is. So we do this computation. X is itself minus 3. That's where we get this negative 2. We store that value in the kth element of v. At this point, k is 4. So this will be the fourth element of v, negative 2. And now k gets updated to 5. And now we ask, the loop asks again, is x greater than 0? At this point, x is negative 2. So it is no longer greater than 0. And the loop ends. Okay. So when I run this loop, you can see that v is indeed the vector that we outlined here. K is 5, and you can see all the steps beforehand that we just tracked ourselves. You might notice that we didn't actually keep that element, that number 10 there. That didn't show up in our vector v. And if we had wanted that to be our first element of v, we would have had to start this outside of the loop. So if I say v of 1 is 10, now I've initialized that first element of v. So when I enter the loop, I would want the second element of v to be this updated value. So k would then start at 2. So for this loop, now before the loop, x is 10, k is 2, and v of 1 is 10. So let's see what this is going to look like. Oops. I'll just update the values here. So before the loop, k is 2, v is a vector with one element, or it's just a number at this point, 10, and x is 10 as well. So now, when I go to enter the loop here, I'm now gonna have that first value that I want to keep track of. So now this is x is going to be updated to 7, just like we saw before. Now, since k is starting at 2, this line starts with vk. So vk 2, k is 2 at this point. So the second element of v is going to be x, which is 7. So now I get the first step of my iteration. I have v is 10, 7. And this will continue, we'll continue to have, k will update to 3, and we'll be able to track the entire, all the values now from 10 down